3I Atlas just lost 99% of its mass, and according to the laws of physics, that should not be possible. In less than 90 days, this interstellar visitor appears to have gone from a 33 trillion kilogram giant to a 260 billion kilogram ghost. Roughly 32 trillion tons of matter seem to have vanished into the void without an explosion, without a debris cloud, without any obvious sign of catastrophic destruction. What remains is a mathematical anomaly that challenges everything we think we know about how objects behave in space. I'll be honest, it feels like we're watching a glitch in our understanding of reality. To lose 99% of your mass in silence without tearing yourself apart is something a comet simply should not be able to do. It raises uncomfortable questions. Was 3I Atlas ever the massive object we thought it was? Or were we misled by our assumptions from the very beginning? Was it hollow, unusually structured, or something far stranger, adjusting its effective mass as it moved? NASA is searching for natural explanations, but a discrepancy of this magnitude is unprecedented. Between May and September, 3I Atlas became one of the most closely monitored objects in the sky. More than 230 observatories around the world tracked its position with extraordinary precision. We're talking about accuracy down to roughly 0.028 arc seconds, the equivalent of spotting a single coin from over 100 kilometers away. For 5 straight months, the data showed something remarkable. Nothing happened. The object moved exactly where gravity said it should. There was no detectable push from outgassing, no wobble, no deviation from a purely gravitational trajectory. It was quiet, steady, and heavy. In physics, silence is information. If sunlight is hitting an object and gas is venting, yet the object does not accelerate even slightly, then it must have enormous inertia. Heavy things are hard to move. Based on that silence, researchers calculated that 3I Atlas had to be massive, with an estimated diameter of several kilometers and a mass around 33 trillion kilograms. At the time, this conclusion seemed unavoidable. The numbers fit. The models worked. We believed we were watching a mountain of interstellar ice drifting through the void. That confidence may have been our first mistake. We assumed that because it was quiet and unresponsive, it must be solid and enormous. For months, telescopes detected no sign of the rocket effect that comets usually exhibit as they heat up. The sensitivity of those measurements was hundreds of times better than what we see today. If there had been even a tiny push back then, it should have been visible. We built our entire understanding of the object on that absence of motion. Then, as 3I Atlas moved closer to the sun, the story changed. In December, new observations finally revealed a small but measurable acceleration. It was subtle, just a whisper of motion, increasing the object's speed by roughly 13 kilometers per day. On its own, that doesn't sound dramatic. But when scientists plugged that acceleration into the equations, everything collapsed. To produce that amount of push from the observed gas flow, the object could not be a 5-kilometer-wide giant. It had to be far smaller and far lighter. The math was unforgiving. Based on the measured gas speeds, around 1,600 kilometers per hour, and a mass loss rate of roughly 150 kilograms per second, the resulting force implied a total mass of only about 260 billion kilograms. That is more than 100 times smaller than the earlier estimate. The mountain vanished. What remained was something closer to a shadow of the object we thought we knew. It feels unreal, as if we spent the summer carefully tracking a blue whale, only to realize in winter that we were actually looking at a goldfish. A 99% difference is not a rounding error. It is not a minor correction. It suggests that either the object fundamentally changed or our interpretation of what we were observing was deeply flawed. Here's the paradox that won't let go. If 3I Atlas was always this light, solar radiation should have pushed it noticeably months ago. Yet hundreds of telescopes saw no such motion. To lose 99% of your mass without an explosion or a visible debris cloud is like watching a skyscraper disappear while you're staring directly at it. Some researchers invoke the idea of an extremely fluffy, porous comet to reconcile the numbers, but that explanation feels strained when pushed this far. In the darkness of space, 3I Atlas is behaving less like a rock and more like something shedding its own skin. It entered our system as a silent giant and appears to be leaving as a ghost. This has led some scientists to ask an uncomfortable question. Are we forcing a natural explanation onto something that might not be entirely natural? That idea usually stays on the fringes of academic discussion, but the numbers here are so extreme that alternative interpretations refuse to go away. If the mass never truly existed, if the object was never a solid mountain of ice and rock, the paradox disappears. In that case, what we perceived as a massive body could have been a thin structure, a hollow shell, or something with an unusually low density that only revealed its true nature once solar radiation began to push on it. This line of thinking has led to provocative suggestions, including the idea that the object could behave like a light sail, responding to radiation pressure in ways that mimic mass loss. It's a disturbing possibility, but it neatly explains why the object appeared heavy and inert when far away, yet became responsive as it approached the sun. In that scenario, nothing actually vanished. We simply misjudged what we were looking at because we assumed it was a rock. Others argue that hidden asymmetric outgassing could still explain the behavior and that 3I Atlas is simply an unusual comet. That may yet prove to be true. But the sheer scale of the discrepancy makes it hard to ignore the sense that something doesn't fit. The motion of this visitor feels less like an accident and more like a controlled adjustment, a quiet shift in how it interacts with its environment. If 3I Atlas is nothing more than a fragile comet, then it is unlike any we've ever seen. If it is something else, then we may have briefly shared our solar system with a truly anomalous visitor and spent the entire encounter trying to force it into categories that were never meant to contain it. We are like ancient sailors watching a modern ship and arguing about which wind must be pushing the island. NASA's models struggle because they are built on the assumption that everything out there is either rock or gas. 3I Atlas is hinting at a third option, something that slips through our definitions, a ghost in the machinery of our understanding, refusing to be weighed by our rules. As it begins its long journey back into interstellar space, we may never get another chance to look inside. We are left with two conflicting realities: the silent giant of summer and the lightweight ghost of winter. Maybe the math is wrong. Maybe our models are incomplete. Or maybe the universe has just reminded us that the space between the stars is not empty, and the rules we rely on do not always apply there. Whether 3I Atlas was a fragile comet shedding itself apart, or something far stranger adjusting its drift, it has left a hole in our understanding measured in tens of trillions of tons, and that absence may matter more than anything we observed directly. Until the next visitor crosses the silence, we're left staring into the void, trying to make sense of what slipped past us.